project name is Automatic Constant Voltage Auto Transformer Twin Test Station using Mitsubishi with PLC. Internal guide name Karthik Kumar, external guide Mr. Sundeep, and the project is presented by Anish George, K. Chinnakesava Reddy, B.B. Vignesh and Bevin Shashikumar. Ballast. A device required by electric discharge light sources such as fluorescent or HID lamps to regulate voltage and current supplied to the lamp during start and throughout the operation. Why do we need ballast? Electric distribution systems deliver fixed AC voltages and expect connected electrical loads to limit the current drawn from the source. Low pressure and high pressure arc discharge lamps without negative impedance without a ballast. The arc will extinguish or draw increasing current until some circuit element burns up. Ballast provides system stability by limiting the current that can be drawn. Ballast use inductive and capacitive components because they impede alternating current with little power consumption. Resistive components generate high loss and usually avoided. This is true of conventional electromagnetic ballast as well as electronic ballast. Constant voltage auto transformer. Present day constant voltage auto transformer ballast for metal halide lamps have changed very little. Versions with igniters to operate pulse start lamps are available along with a wide range of wattages. CWA ballast have two coils. One acts as an auto transformer with multiple input taps and a second provides inductance that in series with the capacitor controls lamp current. For standard probe start designs, the capacitor usually connects between lamp and the secondary coil of the ballast. In pulse start designs, the capacitor usually connects between the primary and secondary coils. A tap near the lamp output on the secondary coil is connected to the igniter circuit. CWA circuits have been modified for HPF lamps but use more materials under certain higher losses. This is also an issue for metal halide lamps that rise in voltage with aging, result in lamp-to-lamp power variation that shows up lamp-to-lamp color variation. The picture that you see on the side is an explanation for the circuit. Objective of the project. Project area Automatic Constant Voltage Auto Transformer Twin Test Station using Mitsubishi with PLC is a twin test station which is used in automating the testing process of CWA ballast. After the implementation of the testing processes was cut short by 1/3, averaging the ballast testing to 300 ballast an hour, saving up to 6,000 rupees a day, making an increase in the overall profit. Existing system. The primitive testing method used is one which the personnel has to connect the wires of the ballast given the input current and check whether all the values are correct as mentioned in the product report visually. In this process, he has to visually check whether the values are correct or not. In the existing system, there are three ways of testing a ballast. They namely E, ER, ATP. Although these systems are automated and do not need visual inspection to check whether the ballast is pass or fail, they are relatively slow. These are the loading time of various types. E and ER has a loading time of 25 seconds, ATP has 20 seconds. These values are an average of 5 observations. Drawbacks of existing system. The main drawback of the system is that they are slow, taking into account the 25-second loading time of a single ballast. The output from the machine is a mere number of 144 ballast. Another drawback of the system is that only one ballast can be tested during the particular interval. During the entire process, the operator has to keep his hands on the testing machine in order to enable the interlocking mechanism. Only when the interlocking mechanism is enabled, the testing starts. It is also a safety measure. Proposed system. Our proposed system, the twin test station, as the name suggests, is a station that enables twin testing at the same time. It has been developed to reduce the loading time of the operator, thus helping increasing the overall output of the production by threefold. This system was developed with the help of PLC. Once the ballast is connected to the testing station, the operator has to just swipe his thumb on the starting switch to start the process. Once the process is ongoing, the operator is free to connect another load, thus saving the connecting time. Unlike its ancestor, the operator need not keep his hand on the swipe switch the entire time of the process. The switch comes with a sensor type safety mechanism which disables the system when the operator is near line. Advantages of the proposed system. The cycle time is 8 seconds, due to which the loading time can be taken as an average of 12 seconds, which means that the 300 ballast can be tested, increasing the overall production to threefold. Twin testing can be done simultaneously and connecting time is reduced. This page shows the technical section. The ballast which was tested was CWA ballast V90D7613, which is a 400 volt core-tab ballast. As you can see, these are the ballast specifications included. processes involved are: the operator starts his daily routine with the validation process. The validation process has two tests, which involves the testing with kit, which has a 90 kilo ohms resistance and a current rating of 0 to 30 amps. The tests involved are: pass test. This involves passing 900 volts for 5 seconds through the kit. Showing a value less than 10 milliamps means that the test is a pass. Fail test, which involves passing 1100 volts for 5 seconds through the kit. Showing a value more than 10 milliamps means that the test is a fail. After the test is done, the reading are noted in a register and verified by the section supervisor. Only after this process does the operator starts the testing of ballast to ensure integrity. Testing process. The ballast is brought for final testing using a conveyor belt. The ballast is then connected to the ATP station manually by the operator. It is connected with the circuit diagram provided by the engineering department. The connections of CWA are provided to the pins as follows. These are the pins to which the wires of the ballast are connected. R cap means capacitor connector. T1, T2, T3, T4 are the voltage tappings. Line, the black wire. COM is a common wire. Red is red color wire used for igniter. Blue is the blue color wire used for igniter. WH bar RD, white red wire used as side wire. CAP, mu H is auxiliary capacitor if there is any. This is a block diagram for our project. The entire process starts with the push button. From the push button, the signal is transferred to PLC. From the PLC, the signal is transferred to the HMI, where all the product details are given. At the same time, it travels to the relay. As you can see from the PLC, there are two signals. One is to the relay, which is a fixed voltage from the variac, and the other relay is a contactor which can be changed according to the ballast. The sequence of testing is as follows: input voltages and test voltages, magnetizing current, tapping voltages, open circuit test, short circuit test. After the sequence of these tests, the high potential test is done to check the dielectric strength. High pot test. The process involved is as follows: 2.5 kV of voltage is passed through the ballast for a time period of 2 seconds to get an output near to 10 milliamps. During this process, the sparks can be seen. After this process is checked and verified, the machine is passed OK and painted at the bottom of the ballast. These are the observations that were taken during the testing of ballast by an operator. As we can see over here, the input voltage is 227 volts. The test voltage is the maximum 277 volts, obtained 276 volts. Magnetizing current maximum is 0.92 amps, obtained 0.84 amps. Tap 1 range is 118 to 122 volts, obtained is 119 volts. Tap 2 range is 210 to 214 volts, obtained is 212 volts. High port is 10 milliamps. MOS maximum overall size is 4 inches. Tap 3 range is 225 to 240 volts, obtained is 238 volts. Open circuit voltage is from 239 to 255 volts, obtained is 252 volts. Igniter maximum is 8 volts, obtained is 7.3 volts. Short circuit current is 3.75 to 4.07 amps, obtained is 3.92 amps. As you can see, all the values that we got are inside the range, therefore the ballast is a pass. Hardware and software. Software requirements are GX Developer, eDesigner. Hardware requirements are transformer 240 volts 550 to 60 hertz, transducer 57 to 400 volts 1 to 9 amps, human machine interface 240 volts 1 amps, cooling fan 230 volts, contactor 415 volts 18 amps. These are the pictures for the HMI or the human machine interface. As we can see, it's a fully touch enabled system where the operator has to feed inputs through a touch screen. The values that you see over there are the values that we get when a ballast is tested for voltage and current. The second diagram shows how a connection is made. The machine that you see over there is our project, the twin test station. This is a pic of a hardware kit. It's a model kit, and unlike our original machine, it does not have any parameters, just one parameter, the voltage. The voltage is taken into account during testing. Conclusion: after the implementation, the testing process was cut short by 1/3, averaging the ballast testing to 300 ballast an hour, saving up to 600 rupees a day, making an increase in the overall profit. Implementing this testing machine, we make sure that a faulty product is not sent to the customer. 100% quality tested product is sent for verification and packaging.